Hi everyone, today we're going to be looking at the EasyPLC Simulator Robotic Cell, BRX Do-More PLC. Now this machine simulator, or MS, is part of the EasyPLC software suite. It has many built-in machines that are used to show different programming techniques. The robotic cell example is one of these machines. This will demonstrate a sequencer example. The logic will step through different steps in order to perform the task. In this case, an engine is lifted and placed onto a rack by a robot. We will be using the BRX or BRX Do-More PLC and the Do-More Designer programming software to program this EasyPLC machine simulator engine loader of the robotic cell. This will be done using Modbus TCP or Ethernet for communications. The program will allow you to start, stop, and jog the sequence, so modifications of the EasyPLC robotic cell will include controls for this operation. Using the 5 steps for programming development, we will show how this sequencer is programmed. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So the first step in programming this is to define the task. So this is step 1 of our EasyPLC robotic cell. So let's go into our machine simulator and we'll hit start. And our engine loading is right here. And if I click on it, you will see that we have what has to happen. And it basically says, use the industrial robot to load the engine blocks in the pallets. Manage the conveyor stops to place the parts in their position, and a robot to load the engine block in the pallet. Once loaded, release the pallet. The robot moves with the PLC digital I/O signals. So what we'll do is just call up our demo mode in our engine loader. And what this will do is give us a good indication of exactly what has to happen. So here we are looking at our demo mode, and you can see our engine block is coming and our pallet is here. And here is our robot. If we view the I/O, we can see that the robot we have several different I/O, and the engine block is loaded into the pallet. The robot then lets go, lifts it up, and then proceeds on. And our next engine and our pallet come in. Now we have modified, as you've seen above, with our panel that we have right here. So in order to actually view exactly what has to happen, we can also exit out of here. And what we'll do is go back into our machine, but this time here we'll go into start mode. And it's important to know exactly how each I/O is actually going to be performed. So we can hit view I/O. Now, after we define what has to happen, then we're going to find the inputs and outputs, which is step 2 of our EasyPLC robotic cell. So here we can call up the I/O, and when we do, as we enter or hit each bot, we can see the operation. So here we're stopper. We turn it on, turn it off, and you can see it pop up and down. Stopper 2 is right here. And then we have conveyors. And then we have our robot home. And then we have robot take part. So we can actually step through each one of these, lift part. And then we can do a load part. So you can see as the robot, I give it what has to happen, you'll see the robot stop over here, which is the digital inputs coming back in. So robot elevate. So you see it goes off and then comes back on again. So it's important to understand exactly what each one of these are doing in our control. So then we also have our engine create. So if we turn on our conveyor belt, we have our 2 stops. We can do our engine create, and that's how our engine is created. Then we have our pallet is created by this light 2 visible. And there's our pallet. So that's how we can determine exactly what's happening. And you can see as our engine hits this, our first inductive proximity switch hits, and our second one will hit when the pallet is onto the stopper. Then we've added our electrical green button, red button, yellow button, emergency button. So I can move over. We have our camera position here, and I can move in our scene over to our panel that we created previously. There we go. And you can see that I can hit the green button, and the green button goes on and off. So that's our start, stop, and then our jog for our sequence. And then we have our e-stop, which will be our reset for our sequencer. And then again, our load, our robot, we can just take that home. So we can quickly do that and figure out exactly what has to happen. Now, the third step of our EasyPLC Robotic Cell is to develop a logical sequence of operation. Now, a flowchart or sequence table is used to fully understand the process that needs to be controlled. So this process would be in conjunction with all the other inputs and outputs. So what has to happen when, and it has to answer questions like what happens when electrical power or air is lost? What happens when inputs and outputs fail? And do we need redundancy? Now this step is where you're going to spend most of your time programming. Understanding everything about the operation will save you time. It will help you prevent you from continuously rewriting the PLC program logic. Knowing all the answers up front is vital in the development of the PLC program. So in order to facilitate this particular one, we're writing a sequence table. Now, here is the sequence table for the robotic cell. If the input conditions are met, then the outputs are set. The next input conditions are looked at, and if they're equal, then the next outputs are set. This will continuously cycle through the table. Now remember, a PLC programmer must know everything about the sequence and operation of the machine before programming. So ask questions or view existing documentation to ensure that you know the logical steps of the machine operation. So once again, we have our inputs here. So when those input conditions are met, then the outputs are set. It looks for the input conditions again, and then the outputs are set. So it continuously goes on, and then we get to the end of it, and we go back up and circle again. So writing this out will actually help you in understanding truly what's happening within this controller and this operation. So that is the third step, and that brings us to the fourth step of the EasyPLC Robotic Cell and program development, which is developing the BRX Do-More PLC program. So in order to do that, we will call up our Do-More Designer software right here. And on our Do-More Designer software, the first thing we will do is look at our system configuration. So we will go down here to system configuration. And in here, we will look at our IP, or the internal Ethernet port configuration, which is currently set for 192.168.1.11. We'll hit the configure button, and we will we've set up a static IP address in this controller. Now it's important to use a static IP so that we can always see where this is within the network of our system. So let's hit OK. Then we can also look at our Modbus TCP server configuration, because this BRX Do-More PLC will actually be our server, and it will take commands from the EasyPLC machine simulator of a robotic cell as the client. So the client will communicate to the server, get the answers. So here we have the enabled Modbus TCP server checked, and then we can look at the Modbus TCP settings. And you can see here that we've left everything as a default with our default TCP port number 502. Let's hit OK for that. And we'll hit OK for that. So those settings must be used when we're communicating from our EasyPLC simulator. Next, what we'll do is take a look at the actual hardware that we have. And the hardware you'll see is we have the BRX Do-More right here, and we are communicating to the programming software package on the Do-More Designer through this Ethernet port. We're also communicating our Modbus TCP through that same Ethernet port on port number 502 as we just set up. So that's how the actual physical hardware. Now, if we look at our software of our Do-More, the first step here, we will be starting a robotic cell, and we can start it by using the physical I/O, this X0, or the X1 will stop it. Then we have our machine simulator stop, which is coming from MC6. Now, all Modbus communications go through the Modbus area within the BRX Do-More PLC. So all of our inputs come through MC1 on up, and all of our outputs are MI1 and up. So, and then we don't have when we have our sequence stop or reset, then we turn on a robotic cell output, which is Y1. When Y1 is on, it seals this in. You can also see that we can start it from our machine simulator start button, which is that green button that we saw previously. Then we have a timer that's part of our sequence of operation in our sequence table that we saw, and we can turn that on and off, and that's 500 milliseconds or half a second. Then what we do is we set up all of our outputs. So our outputs are controlled by a pointer, and that's our output pointer is at V51. And we can indirect address these values to the bit level. So in this case here, the V51 points to the address in which we are going to put the information. And if we refer back to our sequence table, you will see that our address will be 200 to 205. So that is our addresses there. So going back to our Do-More Designer, you can see that V51 is going to contain the value 200 to 205 in order to get those values in there. And right now we've said the bit 0 of that address that we pointed to. So that turns on our conveyor as long as our robotic cell is in the run mode. Then we have our stops, we have our robot movements, then we have our engine create. So what we're saying here is if we're running, then the output comes on, but if we're stopped and the output is still on, we're going to keep it on. So that way we're not creating multiple engines within our environment. As well as our pallet, same operation will happen there. Then we have our lights for our beacon lights, our red, yellow, and green. And then we have our time delay outputs. So that's all of our outputs being set by that table. So I set them automatically in that one rung. Next, what we do is take a look at our inputs. And again, the inputs come from MC1 to MC4, and that's our limit switches, or our switches, and our robot movement detection. So that's all done there. And that brings it into V60. So 60 is our input word for our control. Then what we have is our pointer here. So we say if it's running, and this is my V60, my input word, is equal to my pointed address word to start. All right, that means they're equal. Then we increment our input pointer and our output pointer. Then what we do is we say if it's not running, then what we can do is use the jog functions, as long as the reset's not there, to increment both our input and output as well. And finally, our last step is saying that if our input pointer is greater than or equal to 106, So that's actually past our last value here on our sequence table. Then what we want to do is we want to copy 0 or 100 into our input pointer, which points to the starting address again, and 200 into our output pointer, again resetting our sequence. So that is our program that we have here. So what we want to do is make sure that's in run mode, which it is right here. And we are all set now, because now we have developed the BRX PLC program. Then what we want to do is go on to step number 5 of our program development. And that step number 5 is the testing of our program. So the step 5 of our EasyPLC Robotic Cell. So let's go back to our machine simulator. And here what we had no PLC connected. We're going to restart this machine. There we go. And again, we have no connection here. So we restarted it. Let's hit the I/O drivers. And we will select our Modbus driver. We will hit the configure button. And on the configure button, we know that we're using the TCP IP port here. And there's our number that we've had programmed, 192.168.1.11. And our digital inputs, we have 14 of them. And our digital outputs, we have 8. So hit OK. Now what we can do is now assign all these driver outputs and driver inputs to the PLC inputs and PLC outputs. We can do that manually by just moving it over, or we can hit driver automatic assign, which is much easier to do. Then we can hit exit and start driver and exit. When we do, we can see now that we have everything now running. We can view our I/O, and what we can do now is just move over to our switch or our panel that we have here. Back out a little bit so we can see the movement, and we can actually start our unit. And here comes our engine down the block, and when it stops, it'll hit this proximity sensor, giving us the next position. Robot picks it up. We'll wait for the pallet to be in position. We then move that over. So again, our sequence can be exactly the same, or it could be a little different depending on how we want to program it. And we see that we have our speed or our time frame. We can speed that up or slow that down. So what we did say that we could do is actually stop this unit at any time and proceed with a jog function. So we'll go back out a little bit here. And what we can do is we can hit the stop function. There we go. So we've now stopped our sequence of operation. Let's go back to our panel a little bit. And we'll just zoom out a little bit here. And we have our jog located right here. So we can actually jog the sequence. There's our lifting apart. And then moving it over, setting it down, and back up, homing, and then we're back at the beginning again. Then we can go start again. So very easy to manipulate this as we use the program, and we can actually monitor this using our data view on our Do-More designer. So when we call up our data view, we can debug, and we call up our data view right here. So we can call it up, and when we do, we can actually monitor this information, and we'll put it we'll put it over here as our operation continues. So you see here's our conveyors and what status they are. We can go down and there's our inputs and what status they are. We can see our pointers and the different variables. So we're at 105, and you see it now resets and we start back again. There's my input conditions currently and my input pointer conditions. So what we'll do is just speed that up a little bit and show you that time frame. There we go. And we can also take a look and zoom around this scene. Now, if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Thanks so much for watching. I'll see you next time. Stay safe.